The Python interview question goes like this. You will be given a list of size n and it contains values that are distinct from 1 to n. The question is you will have to write a Python logic where you can check if these list of elements are all distinct between 1 to n or if there are any duplicates or any issues. Let's first see the bad logic. You will be iterating through each value in the list and comparing each value with the entire list, and you will have a temp counter. Whenever you encounter the value more than once, you will increment this temp counter by 1, and if this temp counter is greater than 1, you can just break and print a message like encounter duplicates. This is bad logic because the complexity is n multiplied by n, that is O of n square. As this keeps increasing linearly, the complexity increases in O of n square way. But there is a better solution, that is O of n. For that, we need to use a mathematical formula, that is sum of first n integers from 1 to n. Let's consider the sum of first n values as s. To derive a formula, we'll just use a simple trick. We'll take two series of same 1 to n, but the second series will be reversed. We'll add these two series and each of this sum will result to n plus 1. How many number of times? N number of times. That is 2s equal to n into n plus 1 is equal to n into n plus 1 by 2. So this is the mathematical formula that will give us the sum of first n integers. Now let's see the good logic. Here what we are doing is, we'll first try to calculate the sum of n integers using the formula, that is n into n plus 1 by 2. N equal to size of length of the given list, and we'll have that value here. Next, we'll just iterate through this given list once. What we'll do in these iterations is we'll just calculate sum of all integers that are present in the list. If these two sums don't match, then for sure there is a duplicate. If they match, then your list is perfect. Let's see one example. Here sum using the formula is 55 and sum by iterating through this list using for loop is 55. They both match, so the list is perfect. Let's introduce a duplicate. There is a duplicate, check the list once. The complexity of this logic is just O of n. It fits here. Although technically it's not O of n, it's O of 2n. The reason is this length of given list, this function uses internally behind the scenes a for loop. That for loop iterates n number of times. It's not n square, it's n number of times plus n number of times. The complexity falls somewhere between here, O of 2n, above O of n and below O of n square, somewhere here. So it's still much better than O of n square. That's all for today. Thank you.